How's it going, everybody? I see there's only two viewers in here right now. I know this event wasn't really pushed too much, but I'm glad you guys could join us. And welcome to our first CP164 review session of the term. We're going to be having these, we're going to try to have these bi weekly, but yeah, I think the first two review sessions, this is going to be the first one, and the second one will be the midterm review. Um, but yeah, let's just hop right into it. This is kind of a condensed review session. We're going to be talking about classes, abstract data types, and then expanding on those abstract data types and talking about some specific abstract data types or data structures called stacks and queues. So, um, before we get started, for the two of you in here right now, can you just sign in using this link? I will send it in the chat as well. If the QR code isn't working, I'll just keep it up for about a minute. Yeah, we'll get this on your Laurier experience record. And if anybody's watching the VOD after the stream happened, you guys can also sign in. Yeah. Okay, so let's just hop right into it unless somebody types in chat and says they need more time. Let's get it going. All right. So let's look at kind of how we're going to do this term's review sessions. So we're going to start off with today's review session, session 1, and then session 2 will be the midterm review like I was saying before. Session 3, we'll dive into linked list and linked recursion and recursion itself. Session 4 will be on binary search trees and hash sets, and then session 5 hopefully will be the exam review. Stay posted on the Discords, on Instagrams and whatnot. We might change these around as the term progresses, but as of right now, this is our current session schedule. So for today's agenda, we're going to be looking at what are data types, or data structures, sorry. We're going to define the concepts of data structures and what they kind of constitute. What are classes? We're going to define classes and objects and how they're implemented in Python. What are abstract data types? We're going to be defining an abstract data type and kind of demonstrating how it's different than a data structure. We're going to be going over some data structures such as stacks. So we're going to be explaining the concept of a stack and where we can use it in a practical sense. And the same thing for queues. We're going to be explaining the concept and where we can use it in coding. So I'll pass it off to Mila and she'll start explaining what data structures are.
Hey guys, can you hear me? Just to make sure. All good?
Yep.
Okay. So let's start off. So what are data structures? Let's go to the next slide. So to define it quickly, so data structures are objects that efficiently store data to perform certain operations. So we have different cases require different methods of accessing data, and data structures provide an effective abstraction to allow for such operations to occur. So different data structures are used in different cases, mostly where they're most suitable for. So some problems a stack can answer it better, sometimes a queue, sometimes array, a tree, and etc. These are just some examples of some data structures. You guys will be learning this term. So their main function is to store and perform operations on data. So let's go over to the next slide. So why are data structures useful? So one, it's the magic of simplifying the process of storing and accessing data. So in Python, you already have some basic implementations of certain structures. So those include, you've probably already seen them before in like 104, lists, sets, dictionaries. And so this is just it's Python's way of making life easy for you, basically, but that's not the case for all of them. So for example, so here you have the second point. So they provide easy to use methods and access to change the data that they hold. So you can also use, you can make your own custom data structures to, bring more functionality and make your own program more efficient and let it serve whichever need that you need it to. So, all right, that's kind of the overview of just what data structures are and what they do. Let's talk a little bit more about classes in particular. So what are classes? We've got, a class is a template for creating an object. The best way and the way that I like to think of it as is a blueprint, and it's a blueprint for an object to follow. So it's gonna going to define it, and it's going to, show us its behavior, or show us its behavior kind of. So classes define the data and behavior of each object through variables, which are your attributes, and functions, which are your methods. So, and it constantly reuses these properties, and this just allows for more consistency within programs. Whenever you use an object, it'll always act the same way. So provides the way of object-oriented programming is kind of this better design towards programming, and you guys will have probably already been using that. I think you guys use the food class, if I'm not mistaken, this sem, that's what you guys do. So for an example in that, even so, like an attribute could be like the self.name or self.origin, and then some methods, for example, could have been I'm pretty sure you guys overwrite the equality operator, so that could be one, or the write method, so you're writing to an open file, things like that. So let's hop over to the next slide. So class structure, so here we go a bit more into depth. So attributes, methods, I like to remember them by attributes are like your characteristics, and methods are like your behavior. So we've got public versus private attributes. The funny thing about Python is that there's no such thing as actually private attributes, but a way that we kind of differentiate from public and private, and it's good practice to do this in Python, is by putting that underscore, which I'm at the beginning of before you write the variable, you put that underscore, or the method as well. The method, not the variable, my mistake. And so that kind of separates the public versus private. But in Python, there's actually like private attributes, aren't actually a thing. But so within a class, it can be defined public or private. Good practice to define it as private with the underscore. And so public attributes are accessible by all objects, and private attributes aren't supposed to be accessed outside of the class. And so it's the same thing with methods and attributes. And so, okay, so here we go with the methods. So categories of methods, we can have constructors, accessors, mutators, iterators. So a constructor is going to initialize the instance of the class. So that's going to be your underscore I and IT underscore. That's your constructor. We have accessors, so they return values of the attributes. So for example, like the get method, mutators modify values of attributes. That could be like the set method. And then we have iterators, and they iterate through the contents of the class. Because technically, when you start getting more into the more complicated data structures, you'll see that like stacks and queues and all that, you're not technically supposed to be reaching in and grabbing a piece of data. That's the whole point of making it private. So you have these iterators implemented inside of the class to help you go through the data structure and extract all of its contents. So let's hop to the next slide. Let's just look at a quick example. So we have our class pets. We have our attribute at the top, our variable pets equals 0. We've got our constructor. So here we have the self.pets equals pets. And then we've got our accessor. So we're going to get the current pet, return self pets, pretty explanatory on its own. We've got mutator method. So here we're going to change something, we're modifying the value. So we're going to append a new pet, we're going to append pet. And then we've got our iterator over here. So we're starting it self.n at 0, kind of think of that as like your index. The n is the value of the iterator. And then we've got the next method. So here we've got pet equals self.pets, and then we've got the next, so we've got the current one, and then we're saying +1, so we're trying to get the next one after that and return it. And so like if you look closely at these, you'll see, so the iterator, we've got it private, and we've got next is also private, and obviously the initializer is also private. You see with the underscores, these two methods could be used outside. And there we go. go for that. I'm gonna pass it over to Noah right now, and he's gonna walk you through abstract data types and some data structures.
Hi everyone. Do you hear me okay, or
Yep, you're
just
good.
get confirmation? You can hear me? Yeah, okay, good. My name is Noah, and we're gonna go over ADTs. So abstract data types, or ADTs as they're often like shortened to. So what they are and how they are used to create data structures, because they're a very important concept to understand when taking CP164, and they're pretty important in computer science in general. So let's learn about them. So what are ADTs? An ADT is just a collection of data and a set of operations on that data. So it stores some information and it does stuff with the information. Like built-in data types, like the built-in data types of Python, abstract data types have characteristics and operations associated with them. Pretty straightforward. And we implement ADTs using classes. So before, when Mila was talking about classes which have different methods, attributes, etc., we can implement the theoretical concept of an ADT in a practical sense using classes, because classes let us in a concrete way implement these attributes and implement these methods. So ADTs versus data structures themselves, because there's often a bit of like lack of clarity over the difference. So we want to clarify that for you guys. So an ADT describes its theoretical functionality, while a data structure actually implements it. So this here says ADTs are the interface that users interact with, but that is clearly a typo because that's not true. ADTs are the concepts themselves. These concepts typically originate from math. An example of an ADT could be like a directed multigraph. That's something from math, but it's something also that could be implement code. But so the ADT itself would theoretical concept, while the data structure is the practical implementation, and it's what the user, or I guess the programmer, is going to be interacting with. Regardless of the data structures used to implement the functions, the use of the ADT should not change for the user. So yeah, regardless of how the ADT is implemented, the ADT as a theoretical concept is like an objective idea, typically coming from math, as I said before. But yeah, so even if like one implementation of a hash set is different from another implementation of a hash set, the concept of a hash set is an objective thing that doesn't really change. So stacks. So now we're going to learn about an ADT called a stack. So what are they and how do they work and why are they useful? These are some big questions about stacks that we're going to answer. So what are stacks? So in real life, imagine you cook a meal for multiple people and you finish eating, have the plates, and you want to bring the dirty plates from the table to the counter, right? So you'd stack them up and then you'd bring this stack of plates to the counter from the table, right? So this is an example of how stacks are implemented in a practical way, but we'll show that in a bit more clearly going forward. So a stack is a data structure where data is stored and retrieved, where the last element inserted, first element removed, last in, first out, or LIFO as a nice way to remember it. And you can compare stacks to the real world in places like plates in a kitchen or warehouse pallet stacks, because let's say you stack up 4 plates from 4 people who ate together, right? The one on the top is the one you're going to wash first, but the one on the top of the stack is the one that was added to the stack last. So it was last in, but first out. And yeah, exactly. Last in, first out. And so for stacks, we have two main methods of the stack ADT is pushing and popping. Pushing is adding something else to the stack, and popping is removing. So in the analogy of bringing the dirty dishes from the dining room table to the kitchen counter, pushing would be adding another dirty dish to the pile of plates, and popping would be taking a plate pile and washing it. Or I guess washing it wouldn't necessarily be part of popping it, but the removing it from the pile before you wash it would be popping. And why are stacks useful? So stacks are useful in a lot of situations. You might have seen them used in your kitchen sink, home depot, or even a football. And the most popular way that stacks are used in programs are for backtracking. aka finding the shortest path to the end of a maze, or calculating math expressions that use bed math, and many more. So this theoretical concept of a stack is implemented in practical ways to get stuff done really quickly and efficiently that otherwise would have been quite difficult. So here is a sample implementation of the stack ADT as a data structure as a class. And again, even though stacks as as a concept, objective thing, there's no different ways to do it really. It is an objective set of properties that a stack has conceptually. The practical implementations can be different, especially because different languages also do things differently. You could argue that like a stack that's implemented in C is more of a true stack than a stack implemented in Python, because in a lot of ways Python does like some work for you and doesn't make you need to show certain things that C does. So you could argue all these things, but this is just an implementation of the ADT in Python as a class. That's our data structure right here. And you can see there's an initialization method. This initializes a new stack, and it has an empty values list. Here there's push, like we talked about before, and this is going to append to the stack. And here is pop. This is going to pop from the stack. This one here, it's using the built-in .pop from Python because we're just popping from the self.values. There's a Python list. It's a built-in Python method that you all would have learned about in CP104. And then peek. This is just peeking at the top of the stack. This is basically the equivalent of, let's say you have that pile of dirty dishes. Let's say you want to like lift it up and look at it and like see if it looks pretty and stuff, or I don't know. But you want to put it back in the pile because you don't really feel like washing it. So that's what peeking is. And here is another, okay, so yeah, this is an example of a stack being implemented, the stack ADT being implemented in a restaurant situation. So here, we initialize a new restaurant and we say self.plate is a stack. So right away saying that the plate for the restaurant, like the dirty dishes for the restaurant, is a stack. And then we're saying add plate. If we have another dirty dish to add to the dirty dishes, push onto the stack a new dirty dish. This new dirty dish variable is plate. Now, if we want to take a dish from the stack, wash it, we use remove plate. And how we do that? We pop from the top of the plate stack. And let's say, the dishwasher kind of feeling like inspecting the plate, but doesn't really feel like washing the plate for whatever reason, because, sometimes you have to inspect the plate, right? So yeah, that's what check plate is for. And it does peek. We peek from the plate stack. So that was stacks. Thank you very much. We're going to learn about queues now, and I'm going to pass the microphone on to Steven.
I'm back, guys. I know you missed me, but now we're going to talk about queues. So, like Noah did, we're going to go over what they are, how they work, and why they are useful. So, a queue is a data structure where data is stored and retrieved such that the first element inserted is the first element removed. So it's kind of the opposite of a stack. It follows the FIFO kind of principles, where the first item that's pushed into the queue is the first item that's pushed out of the queue. So an array-based queue stores data in a private array but limits access to elements for the user to only the first element. So think of it as literally like a line or a queue, as it's called for British people. I know some people invalidate them, but they are right in this sense. So let's look at these people. Obviously, for this to work in an orderly fashion, the first person who goes into the line or the queue is going to be the first person to get service at whatever kind of service desk or place that they're going to. So this is kind of a practical implementation of a queue. And for the examples that we're going to be looking at, it's going to be very similar. So the two main methods for queues are the in-queue method and the dequeue method. So the in-queue method this is already a full queue, so they're only really using a dequeue method, but the in-queue method pushes a item into the back of the queue, and then the dequeue method pops an item from the first position in the queue. So let's look at that. Usefulness of a queue. Queues are useful in cases where the first element needs to be processed, such as printers, uploading images, operating systems, job processors, breadth first search, which we'll learn about further into the course, etc. So here's a simple implementation of a queue. So we initialize it here with a values variable equal to an empty list again. All of these are kind of array-based data structures, we call them, because they're based off of the array ADT. Our in-queue method, which puts values to the back of the queue, we just append it to the values. And then the DQ, we want to pop 0, so we want to take from the front of the queue, or from the back of the queue, sorry. And then we're peeking here, so it's very similar. We're just looking at the top, and well, this is kind of a reverse queue is how we implemented it. So whenever we're appending data, just think of it as going this way rather than how we showed in the image going the other way. So the top is the left side, and then the bottom is the right side. And then we're returning values, which just returns all the values, and then the peak, like we said before, is just showing the value that we can actually access. And so let's think of a queue as kind of a grocery store checkout belt. So we're initializing this grocery store checkout belt as a queue. When we add item onto the belt, so let's say, I don't know, the other day I went to the store and I bought some goldfish crackers. I put the goldfish crackers on the grocery store checkout belt. They're the first thing to enter. And then once the cashier removes the item from the belt, it dequeues it. So the first thing being pushed in is the first thing being taken out. And let's say the cashier can only view one item at a time. So whenever she wants to view an item, she can peek at it with the view item method. And if she wants to look at the whole belt, she can view belt just like by looking at a top down, I guess, of the entire belt. But yeah, this is kind of a practical like explanation of how a queue could be used in a real life scenario. So that kind of brings us to the end of our review session. I know there's only one viewer in the chat right now, so if they have any questions, we can take them right now. If not, we can move over to a Kahoot. I know we don't have enough people to even fill up the podium right now, but I want it to still be there as practice, good practice examples for the people who may watch this afterwards. So yeah, let's just get this started right away, I guess. So yeah, I guess I got to join on my phone too, just so we can actually start the game. All right, so which data structure uses the FIFO protocol? So we literally just went over this. So if anybody forgot, then. So it is the queue data structure. Well, would you look at that? I'm at the top of the leaderboard. So how do we define a class in Python? So is it create class, class name, define class name with parentheses, or class name? For anybody who chose green, that is correct. So we define a class this way because it isn't a function. And this is just the syntax of Python. We just say class and then whatever we want the class name to be. This would be defining a function called class name. This would not be doing anything because we don't have the parentheses at the end, so it wouldn't be doing anything. And then this would also just give us a syntax error. So which function do we use to initialize the attributes of a class in Python? So remember what Mila said about private and public functions in Python and how we kind of distinguish them while writing our code. So if you said underscore init ___, which stands for initialize, that would be correct. Both of these, I mean, you could use these as your own functions, but they aren't what we usually use in Python. yeah, this is the standard practice __ init. So whenever you're creating an initialization, make sure to use __ init. Which function do we use to get data from the top of a queue? Is it pop, q, indexed at -1, dq, or inq? So if you said dq, that would be correct. Pop is what we use for stack data type. This wouldn't work because we don't have, unless we implement indexing in our queue, which we didn't in the data structure that we showed off earlier. This wouldn't work. It would just give us an error because Python doesn't really know what you want it to do when you're saying indexing an object at -1. And then enq is to add data to this to the queue. So when inserting an object into a stack, does it go to the top or the bottom? So think about how a stack works. It's a LIFO data structure. So that means it would go to the top because we are adding to the top and then removing from the top, so that whatever goes in first is also removed, or whatever goes in last comes in first. So this is incorrect. This would be no. Top, last in, first out. Sorry. I sometimes stumble over what the definitions are as well because they are kind of confusing. But just remember that stacks, whatever you put in most recently, is what comes out first. So not first in as in most recently in. First in would be least recently in. So last in means most recently in. How do we create a new object instance called test object in Python? So this isn't really something we went over because it's pretty basic, but how do we create a new object in Python? So we have to create an object very similarly to how we create a function or run a function. So we don't really need to use this new keyword. We don't need to create test object, but we do have to add the parentheses even if there are no arguments. This just tells Python that we're kind of initializing something or we're running the class per se to create an object. So that's why this blue one is not correct. But yeah, so whenever you're creating an object, make sure it's a variable name is equal to your class name followed by the arguments in parentheses. So when implementing stacks and queues, which data structure do we most often use? So is it a dictionary, an array or a list, a stack, or an object? So the correct answer is an array or a list. This is because we care about the order that the data went into these data structures as, or data structures in rather. So that's why a dictionary wouldn't work, because whenever we add values to a dictionary, it just gets jumbled up and it's really just sorted based on the keys. A stack wouldn't work because then we'd be using a stack to implement a stack, which doesn't really make sense. And then an object just isn't a data structure. A stack and a queue, they can both be objects in the Pythonic sense, but an object in and of itself is not a data structure. And so that's why array, or list as it's called, is the correct answer for this. But we will see later on in the course how to implement stacks and queues, not using arrays or lists with something called a linked list, which is very interesting and a little bit confusing, but I'm sure you guys won't have trouble with that. So which function do we use to insert a value into a stack? Is it push, pop, insert, or append? So yes, the correct answer is push. Pop is to remove the object from the top of the stack. Insert is a method we use for lists, and append is also a method we use for lists or arrays. Insert, you can give it a piece of data and also a position within the list, and it can insert it in a specific position, and append will just add to the end of the list. So that's the thing about stacks and queues, is that you can't give it a certain place to insert an object or a piece of data, because it would kind of defeat the whole purpose of the stack. The whole purpose of a stack or a queue is that they follow the last in or first in, first out principles. So if we just insert objects wherever we want within the stack, it doesn't really make sense because it just violates the principles. So that's why push, which means we're just putting it at the very top of the stack, is the method that we use for inserting a value. So true or false, Python is an object-oriented programming language. So just try to recall the definition of what an object-oriented programming language is. So the answer is true. Even though people coming from more of a Java background would say it isn't, any programming language that allows you the ability to create objects is inherently object-oriented, and Python is called a multi-paradigm programming languages because it encapsulates a lot of different programming ideologies. You can use functional programming and you can use object-oriented programming, where in Java, for example, you can only use object-oriented programming, and in C, which is a functional programming language, you can only use functional programming. So Python is not only an object-oriented programming language, it's also a functional programming language. So just keep that in mind if it's ever asked on a quiz or a test. So how many items can be inserted into a stack? Is it unlimited? Is it 10, 15, or 100? So for anybody who said unlimited, that is correct. Similarly to arrays, there isn't really a practical limit to how many pieces of data you can put in these data structures, since they all are based on lists. So of course, if you want to insert 1 billion numbers into a list, it's going to cause some lag for your computer, but there's no limit in Python to how many you can actually put in. So since these stacks are implemented using arrays, queues are the same exact thing as this, but since they're both implementing using arrays as their underlying data structure, the amount of items that you can put into them is unlimited or limited to however much your computer can handle in memory. So now that we've finished all of them, let's see who got first place. Third, way. Nice, whoever did that. Second, way. First, way, come on. Drum roll, please, guys. Let's go, your boy, first place. Thank you to all of you who participated in our Kahoot today. But if you guys are watching the video clip on Twitch after, I hope this was good practice for you. Oh, Green Leader, you must have joined too late. My bad. To join the Kahoot. Well, hopefully you enjoyed regardless. But yeah, that pretty much wraps up our review session for today. We can take any questions if there are any. But yeah, I'll leave the floor open for 30 more seconds because I am sick and I would like to crawl into bed if nobody has any questions. Okay, 10, 9, 8, 7, 6, 5, 4. Thank you, Green Leader. I think you're the only person in here that's actually a person, so real as hell for that. But yeah, thank you guys. Have a good night. I'll catch you guys at the next review session. Midterm review, February 24th. Bye.